A very warm welcome to this demo video. I will talk about one of our demo in which we interface thermal camera with FPGA. So I would call this setup as FPGA based thermal camera. In any imaging system, we have a flow of imaging tasks, usually consist of 3 steps: pre-processing, intermediate tasks, and then post-processing. In pre-processing, we have spatial or temporal filtering in order to remove the background noise or to improve the signal to noise ratio. In intermediate tasks, we have, for example, segmentation and some non-linear filtering such as morphology, erosion, dilation, opening, closing, etc. to remove 1 to 2 pixel false objects. And then we have post-processing. The imaging task could be feature extraction, classification. So while performing operation, people usually follow a traditional approach in which they start from pre-processing and ends with post-processing. The drawback in this approach is that the effect of the pre-processing is propagated to the post-processing. If you do not have good pre-processing, you would have the effect of that in the post-processing results. So what we thought in this work is to make a cut in this flow by including a human at this step. So we would extract the region of interest by using some ground truth methods and then test the system with respect to these extracted region of interest. The input to the test systems are 4 different types of images: color visual ROI, binary visual ROI, grayscale thermal ROI, binary thermal ROI. And another input to the system, so here you could see the region of interests: color visual ROI, binary visual ROI, grayscale thermal ROI, binary thermal ROI. And then we perform our analysis on these 4 types of images and 2 types of classification algorithms. So this is classification accuracy figure, which shows accuracy with respect to 4 image types and 2 different classification algorithms. So this is the classification accuracy figure with respect to 4 image types and 2 different classification algorithms. We can see that the classification accuracy of thermal raw and thermal binary is greater than these 2 visual raw and visual binary images, and in between thermal raw and thermal binary there is not much difference if we take the combined accuracy of the 2 objects. The thermal raw ROI requires greater arithmetic operations and have large memory requirement as compared to thermal binary. So we will propose a pre-processing architecture for camera which integrates thermal camera and produce segmented binary image. And this classification study was performed on NVIDIA Tegra TK1. In the rest of the video, you will see a live demo of the thermal camera interface with RTX 7 FPGA.